Okay, so hi everyone, I'm Alex, I'm a developer in BHB Network. Work mostly on Bitcoin related open source stuff. In this case, the thing I'm mostly focused on now is RGB, which is this protocol, which is basically an improvement of colored coin. It's nothing like new and fancy. It's basically improvement of colored coin, and it also works on Lightning, so it could hopefully practically sooner allow people to issue and move tokens around Lightning. As we like to call it, it's basically a really fast XSM. We know people will not do that, but it's probably inevitable, I guess. Just a little disclaimer to make it very clear. We don't like ICOs, we don't want to promote ICOs or anything. We think that most tokens out there are probably useless, or well, basically they are useful for the issuer to get rich. We don't want to do the scams in any way, but still we think this is a pretty cool research project, something that could be done. We don't really believe in changing the, let's say, base layer, so we like to test this kind of stuff on top. Maybe eventually some of the things we will come up will actually make it into Bitcoin. Some other stuff probably won't. We'll see, I guess. And also we would like to provide a solid platform for people that actually really want to make a token. So if you really want to scam people, at least not get scammed by hackers hacking your smart contract, do it on RGB is a little bit more solid, I guess. I will start by making a little recap of RGB. RGB is basically an on-chain protocol which can then be leveraged to work off-chain too. I think the best way to do it is start from the colored coin, like the good old colored coin protocol, where we basically have operators encoding metadata about where we are moving assets. These metadata are pretty much readable and verifiable by everyone, so you have zero privacy. Everybody can look at the blockchain, everybody can see what you're doing. And this is basically a representation, like you have a colored input, well, colored output, which becomes an input in a transaction. Then you have some extra output, one extra output, which says where to move tokens, and you create a new colored output, which can be spent like later on. Starting from this concept, the first thing we actually decided to do is move this metadata off chain, like not write them exactly in an operator. Basically, just to have more space, but also to have like some extra privacy and plausible deniability gains, I guess. And the cool thing, in a way, is that you're not public anymore. Like people cannot look at the blockchain and see what you're doing. It becomes it's kind of in Lightning, where you have a like one-to-one transaction where it's just the sender and the receiver, and when the following owners of an asset which can actually validate proofs. Proofs is basically the name we gave to RGB transaction, RGB transaction. So yeah, we get a little bit more plausible deniability because for an external observer, they just see operators with some random string inside, which is the hash of this data, and we get like a ton of extra space. We could, for instance, for like non-fungible tokens, we could like put the entire CryptoKitty image inside of the token itself, so that it's not on a server somewhere on a centralized server. But we have like a big drawback, is that these data are out of the blockchain, and we have to move them around in some other way. Like I cannot just send you a Bitcoin transaction and you can see everything. I also have to send you somehow this extra data. But this is not a big deal if you are on Lightning. I know this is like a huge issue we are trying to like solve, probably with IPFS or something similar for the on-chain part, but we are mostly focused on Lightning. So it's kind of I think it's kind of a trade-off. We have a bad on-chain experience, but once you're on Lightning, it's basically like you don't have any extra issue at all, like normal Lightning transactions. And one more thing, we can use pay-to-contract to commit to data. So instead of having one extra output just for the commitment, which is I think kind of private, because you can external observers cannot see what's inside, and they could still see that there's this operator output. We can move everything into one of the other output, which is basically a generic pay-to-public key hash output, and we get even more plausible deniability. We save a few bytes and satoshis in fees. And we also get like this really cool thing that an observer cannot even know that this is an RGB transaction. They just see basic generic transaction going on, pay to public key hash, and that's it. And why is this Lightning Network compatible? Basically because RGB transactions are kind of dumb. They don't have like a scripting language or anything. They just tie assets to a Bitcoin UTXO, and then it's up to the Bitcoin layer to decide who can actually spend this UTXO. So if you think about the Lightning Network case where you have ACLCs, we actually don't know who is going to end up like taking this ACLC. It could be the original owner if it turns out, maybe the new owner if it gets resolved with the pre-image, but RGB doesn't care. RGB just ties the asset to the ACLC and then someone will kind of get them. And it's also compatible with the two. Basically because even if we use pay-to-content, in L2 the thing you actually really need is a fixed script pub key, because we have to chain transaction and they need to spend from the same script pub key and to pay to the same script pub key. And basically we can do that with pay-to-content too, because the proof is kind of fixed. You just take everything and send everything to the first output. It won't never change. So the script pub key, even if we kind of do this magical math tweaking, will not change at all. So we could theoretically be compatible with the two when it will actually be ready. I will try to do like an outline of how to move actually onto LM. So this is basically what do you have to modify in Lightning Network, in the protocol, in implementation to actually be able to do that. I don't be like super technical because I think it would be super boring. If you then have any question, I think I have like 30 minutes of Q&A after the presentation. The presentation will probably be like short, 20 minutes I guess. So you have plenty of time to ask questions if you really want the technical stuff. But I will try to skip them for the main presentation. First thing, like the most important thing we have is that we would like to be retrocompatible, which means that if you have an RGB Lightning node, we would like to be able to connect to generic Bitcoin nodes and still transact with them. Just obviously not RGB stuff, just basic Bitcoin transaction, but still be able to do it. So we want to change the protocol to kind of upgrade the protocol in a non-breaking way, so that we can have both, like your RGB Lightning node could be both your RGB Lightning node and your day-to-day Bitcoin Lightning node. First thing you have to do is basically choose some feature bit that is, I don't remember the exact number of balls, but there's one ball that basically allocates feature bit, so you can choose some bits to signal to other nodes that you support one specific feature. So first thing is just to take some feature bits and use them to signal to other nodes that we support RGB, in case they are like interested. We will need to basically define some new messages on the protocol level, because we have some extra stuff to basically communicate with other nodes. Like when we open a channel, we also have to communicate to the other node which asset we want to like put in the channel, the amounts, or this kind of stuff. They're not obviously inside of the current Vault, Bitcoin Vault version, so we will have to basically invent new messages and put this extra stuff inside. We will have to define an equivalent of the Vault tree. Vault tree is basically the vault which defines how transaction has to be basically constructed, so that both parties can construct the same transaction. When they sign, they will basically sign the same thing, so that signatures are like interchangeable. And we need to do that for the RGB part too, mostly because since we are committing into transaction, we need transaction signatures to be valid, so we need to commit to the same data. So even if we are like technically trying to communicate the same thing, we like literally need the proof to be the same, because otherwise the hash would match and the commitment would be valid. So we will have to write these specs, and this is probably the trickiest part. Make sure that vanilla, let's say generic Bitcoin nodes, kind of pass our messages around. Basically because we cannot expect like to have an entire RGB Lightning network, so we have to still rely on the normal Bitcoin layer to gossip around messages, to like announce channels, announce nodes, announce which asset we have on channels for routing purposes. And this is probably the trickiest part, because we have to change in a way the protocol, but we also have to ask old nodes which they don't actually speak this protocol to still parse and pass our messages around. This is the thing we are like focusing right now because it's the hardest part. And once we've done that, we have to kind of solve the liquidity problem for the issue I was describing before. Like, we cannot expect to have full RGB paths. Like, I cannot expect to, I don't know, I want to pay Tether dollars to someone. It's very, very unlikely that I will have like a routing path of only Tether dollars from me to this other person. And basically what we can do is that we can atomic swap in and out of Bitcoin. Like, I can atomic swap some Tether dollars for Bitcoin, route this Bitcoin payment to some other nodes, and then like before the last step, atomic swap once again into Tether dollars. So basically this is transparent to the sender and the receiver. The sender sends out some Tether dollars, the receiver receives some Tether dollars, but in the middle there were like these two atomic swap, maybe possibly even more, that allowed the payment to be resolved. And we also have to gossip once again, so announce around the network these two extra stuff, which are the exchange rate for each asset to Satoshis and back from Satoshis to asset. This is once again needed for the atomic swap part. Like, if we want to do these kind of steps in and out of Bitcoin, we have to know what's the exchange rate. Like, I'm sending you some Tether dollars, I want you to send some Bitcoins to the next node, and we need to agree on the exchange rate, otherwise it won't work. This is kind of an example, like assuming we have this network where dash nodes are normal Bitcoin nodes that don't speak the RGB protocol. We have some RGB nodes, and we have some correlate channels. We want Alice to pay friend some red tokens, but clearly there's no like path which goes directly from Alice to friend. What we can do is that we can still use kind of this path, send some red tokens to Bob, Bob will exchange these red tokens to Bitcoin, forward the Bitcoin payment to Carol. Carol doesn't even know this is an RGB payment, it's not an RGB node, this is just a normal Lightning node. It will forward the Bitcoin payment to Dave, and then Dave will exchange back to red tokens. Obviously, you are expected to pay some kind of fees inside, but I mean, it depends. Like, this is basically a decentralized exchange, so if, I don't know, Bob wants to get rid of his Bitcoin and wants to buy red tokens, he will probably be willing to ask Alice a very low fee because she will give him some red tokens and he will kind of stake his Bitcoin. So this is basically a way if you have a RGB Lightning node and you want to sell or buy one of the assets, you can set a very low fee and kind of encourage people to route payments through you to basically do what you want, sell or either sell or buy an asset. So basically this is how we kind of see RGB. We have our ERC20, which is the crappy stuff. Correlate coins are cool. RGB on chain is a bit cooler than correlate coins. And then there's RGB on Lightning, which is hopefully like the super cool stuff. There are some current no limitations. Some of them are probably going to solve up in the future, some of them probably are not. First, like, huge limitation is that we cannot do non-fungible tokens. You can do non-fungible tokens on RGB, but basically you cannot route them to Lightning Network. Basically, because if you think about it, even like on the Bitcoin Lightning Network, you are not taking Bitcoins out of the channel. It's still like the same Bitcoin that bounce back and forth from the two peers. But since Bitcoin are fungible, you don't care if like the final receiver will receive this specific Satoshi or some other Satoshis. But with non-fungible token, you actually care. You want this specific token to get to the receiver. And maybe I'm kind of thinking about a way to do some kind of splicing without going on chain, so that basically if I have a CryptoKitty inside of a Lightning channel, I can send it to some other peer somewhere else, which doesn't have a channel with me, by kind of splicing it out of my channel and splicing it into his own channel. But I don't know. I'm still working on that. Maybe it will work in the future. I don't know. Another pretty big limitation is that we could get blacklisted from vanilla nodes, from Bitcoin nodes, because even if they don't like speak the RGB protocol, they could see weird stuff going on, like for the gossip messages, and they could, I don't know, maybe in the future decide to block these kind of messages completely, because they might see them as spam or something like that. Obviously, we have no control over basically we have no control on what code a user runs. and we have no control over, I don't know, Blockstream or Lightning Labs, so they are obviously free to decide to do what they want to do with that. They could in the future blacklist these kind of messages, they might not, we don't know. But this could be like a pretty big point to keep in mind. And basically, once again, for the splicing issue, you cannot receive a token if you don't have a colored channel of this token, obviously with some liquidity inside. If I find a way to kind of splicing it out, this could probably apply, like this would be a solution for this issue too, because you could splice some tokens out even and send them to someone else even if it doesn't have a colored channel, but once again, we don't really know, I guess. And that's basically it. It was like very, very short. I didn't want to, I don't know, bother anyone with technical stuff. If you have any question now, you can ask them. We have, yeah, like plenty of time. Thank you. Yeah.
What kind of things can you do with these kind of tokens? So you can issue a token and send it. Can you trade it like textile, or can you do it on dividends or other features?
Yeah, basically, I mean the
question.
Oh, okay, so he asked what you can actually do with a token. You can issue, transfer, or whatever. Basically, yes, you can issue token. The issuance right now we are forcing it to be on chain because we want like an anchor on chain that it's there public forever. So the issuance involves an on-chain transaction. Then theoretically, starting from that, you could move tokens in a Lightning Network channel and never go on chain again. You can trade tokens by doing the atomic swap trick. Like as I said before, if you have a colored channel with Tether dollars and you want to get rid of them, you will actually gossip around a fee, like an exchange rate, which kind of favors people that want to send Tether dollars through you. Like you want to encourage people to send Tether dollars to you and make Bitcoin go out the other way. And in this way, you are basically in this way you are basically buying Tether dollars because you end up with more Tether dollars than Bitcoin. If you want to do the opposite and you want to get rid of them, you will encourage people to pay you Bitcoin and send out Tether dollars. And this could be kind of automatic. Like you don't have to think about it. The client should handle that for you. You basically in your client say, I want to get rid of them, and you basically wait for people to route payment through you. Or you could, I don't know, send them to an exchange if they actually support RGB Lightning stuff. That's basically it. We are thinking about like new ways to make issuance. Like this is the only thing that's like written in the code right now is the basic issuance, like the Tether issuance. But in the future we would like to have the ICO issuance. Yeah, we hate ICOs, but we would like to do it anyway. Which is basically like you can provide the proof that you paid someone in a specific range of blocks, and this proof guarantees you, basically you can print your own tokens by showing this proof. So you don't have to like pay someone and wait for the tokens to come back. You just pay someone, and this payment is itself the token coming back, because you can prove to everybody that you paid this specific address, which is the crowd sale address, in the specific range of blocks. And you can then move these tokens once again into Lightning and move them from it. You could also do the airdrop issuance, if you can once again show that you had a Bitcoin UTXO before a specific block. You are basically, this proof of ownership is basically the proof that you have some token, like the basic airdrop. Like everybody that has a Bitcoin before this block will get 10 tokens, you can do that. And then once again you can move the tokens inside of Lightning Network. That's basically what we had in our mind right now. We don't want to do like, we don't want to be like the general purpose solution like Ethereum. We want to be like very specialized on some use cases and do that like the best way possible, not many stuff in a bad way. Yeah, do you have another question?
Yeah, I also have some questions. So like, if you want to make like an explorer for your token, like your ecosystem is the only one in a position to make that such an explorer and issue it because they can see the full history because they are like party to the first.
Basically, it's kind of okay. Can you do an explorer for your token? Basically, it's kind of impossible because in order to make an explorer, you would have to buy like a lot of tokens. Basically, how it works is that Yeah, as you said, there's kind of a tree that starts from the issuance and then kind of spreads around as people split tokens around. When you receive tokens, you know the entire history, but once you send them, you will not know what comes next. So basically, in order to make a snapshot of the current state, you would have to buy a lot of tokens. Then you can see a lot of history. But then once again, as soon as you move them out, you can send them to someone. You have no idea what's coming next. So basically, doing an explorer is kind of impossible. But we think this is a cool thing. We think this is a feature, not a bug, I guess.
I guess my follow-up question would be, from the use side, there's specific use cases you're focusing on, assuming you get past all the limitations, you perfectly know how it works, and it's where you want it. Could you describe a use that you'd like to see?
Sorry?
Could you describe a use that you'd like to see, or you'd like to see it itself?
Okay, so the question is, what use cases do you see for this project? Basically, as a token, not many. I said $Tether many times because I think $Tether could be one use case. So these kind of tokens where an issuer prints them and then just gets rid of them. When someone comes back to the issuer, it will pay them back dollars or gold or whatever. This could be, I guess, a case. Not many others, honestly. We see this really as a research project. We want to see what we can do to scale. We think this is a pretty good scale improvement, in a way that you don't have to validate everything, but you only validate stuff that you really care about. So maybe in the future, I'm not a shitcoiner, I don't want to promote other currencies, but maybe in the future a blockchain will kind of adopt this concept of validated as few stuff as possible. So it's a research project, it's not a product. We won't get paid to do it. We honestly don't see that many use cases. Even non-fungible tokens can be done, but then you cannot do them on Lightning, so this is not a big deal. It's a research project. We think that cool stuff could come up from this thing to improve Bitcoin, maybe. Tokens are not that good, anyways. Yeah.
How do you keep a limitation on the number? If somebody's issuing this, you send a Bitcoin, you get a reply. How do you keep? I can get 1 million people. How do you stop your supply from growing indefinitely?
For the ICO model that I explained before. Basically the idea is that you can set a maximum limit of supply and the price satoshis per token in the range of blocks when your crowd sale is valid. Then you take all the transactions that pay this specific address, which is the crowd sale address, in this range of blocks. You just basically order them, you look at the block order, and you go from start to when the supply is over. For people that came too late, the idea is that they will get a refund token, they will get a token which is tied one-to-one with satoshis, and then they can ask for a refund in this.
There is trust that you're going to refund.
Yeah, for the refund part, yes. This is, I think, the best way we can do that because we have no control on the Bitcoin layer. On Ethereum, you could do once the cap is reached, we won't accept payment anymore. You cannot do that on Bitcoin.
Right.
The RGB protocol cannot tell Bitcoin don't accept this transaction just because it's something. So the best thing you can do is still issue a token, which is a refund token, and then people can ask for a refund with that. It's not an optimal solution, but it's probably the best you can do without touching the Bitcoin layer. Yeah.
Could you use this to lock up, to map a certain number of satoshis to a token and have them locked up? In the case of thinking of it, and maybe this isn't for your protocol, but if you're familiar with MakerDAO and Ethereum, I was wondering if you could have. So basically, they're over collateralized stablecoin. So they have you want $100 issued every DAI. You have $200 of Ethereum locked up.
Okay.
I was wondering if you could do something similar with Bitcoin. So you want to create a stable coin based on Bitcoin. Or if you use this on that.
I don't think so. I would have to think about it, but you see, the big issue doing tokens on Bitcoin is that you have no control over the Bitcoin layer. So you have no control over Bitcoin transaction, and you want to avoid cases where the RGB protocol says that this is not allowed, but the Bitcoin layer allows the transaction, and then you end up in a state where, this wasn't allowed, but the Bitcoins are there. I received the Bitcoin. Now what should I do? Should I refund you? So it's a kind of a bad state. And to get rid of this, the idea is that we will try to only do use cases where you can avoid this entirely, the only basic issues where you don't have this kind of interaction. The ICO model is kind of on the limit because you have no interaction if your payment goes through, like if you really buy the tokens. But if you don't manage to get into the, I don't know, to be the first, you will get this refund token, and then once again you have to ask for a refund. So what you're describing, I think you would have to kind of, from the RGB layer, influence the Bitcoin layer, like says, now these Bitcoins are locked, and then when something happens on the RGB layer, say now they're unlocked, and I don't think you can do that. You can do that with Rootstock, maybe.
Yeah, that was the other
Yeah,
thing.
but, yeah, because Rootstock has kind of miner cooperation. So Rootstock, I think, locks money into some weird address, and then miners can take them out when they need to. But I don't think like this is a good idea. You are trusting miners, which are anonymous, bad, probably people around the world. So I mean, I think don't do tokens instead of Rootstock. So yeah, I don't think you can do that. Sorry. Any other questions?